All right, how's it going, everybody? For today, we are going to be covering note 6.2, as you can see in your calendar. But a couple reminders before we do anything else. Remember, part of your ticket out for embedded today is to turn in last Friday's homework, which was page 4 through 5, numbers 1 through 22. So don't forget, page 4 through 5, numbers 1 through 22. You are actually going to make sure that you put your name first. Make sure you put your name on that page on page 4. Once you are done with numbers 1 through 22 on the back side, you're actually, for the first time, going to very carefully, and I would push down on the staple there, you're going to carefully tear it out and then drop it off in the homework box. That's because today we are turning in this assignment. Just keep that in mind. Now, with that said, let's go back to our calendar and let's talk about today's assignment. Now, today's assignment, we have 2 of them, so one of these is your ticket out as well. This here is in the packet. This is page 8 through 9. So you're going to do a little less today than last time. You're going to do 1 through 16. And when you see the amount of work you have to do, it is actually some of the easiest stuff we've done. Now, you are going to need a calculator, so make sure that if you haven't picked up a calculator, you will need it. It's going to make your life so much easier for today. The second assignment for today is the one that you will be getting later. This right here is going to be a worksheet /BIM. So for Big Ideas Math, remember, you're going to work out the problems on your paper. You're going to check your answers on BIM and submit on BIM. So that's today's 2 assignments that you're going to be working on. Some of you are new to this period, to this class, and so you will need to get this new BIM code. The BIM code, don't forget, is available through Google Classroom. So go to Google Classroom, press the classwork tab. So if you're in Google Classroom, and you jump right into, let's say it's period 4 just for practice. So here we go. As soon as you get to classwork, so for those of you that are new to the class, whether it's period 4 or period 6, here it is. There is the code, that one right there. Oops, sorry. That right there is the code that you would need, the new code you would need to type in to join this period's BIM. So yes, you do need to join BIM. Okay. All right. So now let's go back to our notes for today. Now these notes are kind of short. They do go by very quickly, especially if you have a calculator. So let's go to page 6. Now remember, we had to number our own pages here this time around. So page 2, there's page 4, the homework from the other day that you need to turn in. Again, put your name. Page 5, so here it is, page 6. That's what we're going to work on. In fact, do me a favor, flip the page. Let's get a couple of these page numbers going. Page 7. Here's today's assignment, page 8. This is your classwork. And yes, it looks like a lot, but it really isn't. Page 9, of course. And you know what? Keep it going. Let's see. Let's get all the way to number 15. So number 10, that's what page 10 should be. If you don't have page 10 with that, then you're labeling it wrong. Page 11, 12, let's go up to 15 at least. Just have our packet ready for the week. Page 13, 14, and then if you're doing this right, this would be your page 15. Okay? So we're just labeling the pages really quick, like I said, just to make sure that we are physically all on the same page. Okay? All right, so once you've got everything up to page 15, now let's get started. Our notes today start on page 6. So let's go back to page 6. Here we go. All right, so page 6. Today's topic is radicals and rational exponents. So we do need to review the concept of radicals and what an exponent is. So these are our 2 core concepts. So the first thing we have here is a little bit of a recall, something that we've already learned in the past, and that has to do with powers. So when we look at the power, right, it says the 3rd power right there. Remember, a power, the true meaning of it is telling you to write the number 2 3 times. So 1, 2, 3. And yes, of course, we're going to be multiplying. This is where we can bring a calculator in And the idea is that if we're multiplying, we'll just either multiply it like this, or of course, we already learned that with a calculator, we can use that button right here, the one with the caret symbol, same one we're going to use today, to multiply it out a little bit faster. And if we use it, there's our answer, 8. Now, on the other hand, we talked about powers. Now, one of the things that we always learn is inverses. So to get rid of addition, we do subtraction. To get rid of multiplication, we do division. Well, there's something in the world here that exists that gets rid of powers, and that's what we call a radical. So a radical is this symbol right here. And notice this one has a little 3 in the box. It's called the index. So that little number is very important there. Again, we call that number the index. And so the symbol itself, though, this one right here, just a symbol by itself is called a radical symbol. So we talked about powers. We're going to talk about radicals. And we're going to talk about that symbol there. So just put it in parentheses. That's what a radical symbol is. But the idea is they're opposites of each other. They're inverses of each other is the correct word. I'm just going to write opposites. They basically cancel each other out. So you see in this problem, they gave me a power of 3. So now I'm kind of thinking the opposite. When I see a power of 3, right, it's the index of 3, they're basically telling me, hey, who did you multiply 3 times? They're not saying put the number 3. That's the question they're asking. What number, it's got to be the same for all of them, did you multiply to get an 8? That's what an index does. It's asking you for that base, that number that you multiply to itself 3 times together. Well, if we look next door, we already know 2 times 2 times 2 is 8. So then that base that they're looking for, that question mark, is the number 2. So the cube root of 8 is just the number 2. And again, this is why we're going to need calculators, because you have to multiply things out until you get a match. But anyways, look, it's here again, a radical. That's the first idea of the day. So when we're dealing with radicals, let's see. We already know it's this symbol right here. Now, whenever we do this, and now this is the only one that you've really worked with in middle school, if they do this and they write a little radical, we have always called it a square root. And the reason we call it a square root is that there's actually an invisible 2 in there. It's so common, there's an invisible 2 that we don't have to write it down. Now, people always say, oh, so it's a 1 because it's invisible. This is the only time that we actually put a 2 in there. Now, if I do this, and it already has a number that I actually see, well, this has a number 3. We call that a cube root. And so notice, do we always say the word root? Instead of saying the word radical, right? It kind of goes hand in hand, though. It's with a root. But it could really be any number we want. So this would be the nth root. And the idea is the same one we saw earlier. Whatever index is here, that's how many spaces I need to put in to try to figure what number it is. So anyways, one mistake, though, that people make, and let me just show you here with another little piece of paper, is this. You have to be careful with the way you write an index. See, some people will write it like this. Let's put a letter in there. And then there's this. See, this is the correct way of doing it. That little number needs to be in kind of this check mark part of the radical. It needs to be in there. This is something completely different up on top. So if I say, give it an index of 5, well, then you got to put a little 5 in here. That would be an index of 5. Again, be careful not to write it like this. If it's an index or a radical, it needs to go in there. So that's just something to be careful with. The only other thing that I want to mention about it is this. The only reason we use radicals, again, we use radicals, and it could be any kind. We don't know. It just depends. We use radicals to cancel powers. It's going to be one of the skills that I need to remember. You've used it before in middle school, but like I said, this is a little bit of review. All right, so here we go. Now we're going to learn about new powers. We're still working on powers. So look how quickly this assignment can go. All right. Now, example number 1, evaluate. So for today's assignment, one of the biggest things you have to be careful with is what does it mean when they say evaluate? And then what does it mean when they say rewrite? Those are going to be the 2 words we have to be careful with today. So when they say evaluate, they're basically saying work it out. And sometimes, most of the time, we're going to use a calculator, but we'll do that later. We're going to work with a calculator in a bit. All right, so here we go. They want to know what is the cube root, right? That's how we read it, the cube root of -8. Now, the negative is on the inside. I'm put a little box for the answer already because I'm going to start thinking about this. As soon as I see that 3 as my index, here's my thinking. I'm going 1, 2, 3. I've got 3 numbers, actually 1 number that I'm going to write 3 times. I want to get a -8 for it. Now, we already saw the 8 on top, so right, there's the hint. But remember, if you're thinking, oh, well, 2 times 2 times 2, that's 8. Well, that's great. You're right. 2 times 2 times 2 is 8, but it says it wants to be a negative. Here's what you can't do. You can't just say, oh, I'll make one of them a negative. Because if you make one of them a negative, you got to make them all a negative because they all need to be the same number. But luckily, with our calculator, right, we can already see that -2 times -2 times -2, and you got to use the negative button. See, there's your -8. So then my answer is -2. Not this, just one of them. We're basically telling people that's the number, the base, that I would write 3 times to get a -8 as a result. Now, when I look at the next one, when I look at letter B, once again, I notice they have a power of 3. But this one does have a negative, but on the outside. Well, here's how you handle that. When you have a negative on the outside, write it down already. That's the first thing you should write down. Because you have to, it's there, well, it's still going to be a part of my answer since it's already there. So now in reality, I'm asking this. I'm asking what number do I multiply 3 times to get an 8? Well, it's the same number from earlier, except this time, I don't need to make it a negative. I'm trying to get a positive 8. Then it's just 2, 2, 2. So then I write the 2 right there. And there's my answer. It ended up being -2 again. Not because the negative was on the inside. That negative was outside, so I just leave it out there. All right, there's 2 problems so far. And then there's this question. Now, this rule that we're about to use is actually on the next page. So I'm not quite sure why they brought this in yet, but I think it should have been the other side first. But anyways, not a big deal. This is not a radical, right? It doesn't look like these, but it actually is. See, in math, when they give you a power that's a fraction, it means one thing. It means this used to be a radical. It can be written out as a radical instead. And the 16 that's there, well, that 16 still in there. But here's the important part. And I know it's kind of small there. Let me see if I can zoom in a little bit more. The index matches my denominator. So the denominator and the index go hand in hand. So if there's a 4 in my denominator, then there's the 4 right there. Again, it's one of our new rules. It means that if you see a power that's a fraction, it just means write it back down as a radical, because that's what it used to be. They go hand in hand with each other. So now I'm ready. Now I can try to answer this problem. And there's no negatives involved this time, so it's not a big deal. But look at what it says. It says an index of 4. So what I have to think of is, what number do I multiply 4 times to itself? It's got to be the same number to get that 16. that yellow 16 that's in there? Well, you can try things out. I wouldn't go too big. Let's see. We know it's not 1 times 1 times 1. So I'm going to go 2 times 2 times 2 times 2. And look at that. There it is. So the number that they keep multiplying over and over and over is the number 2. So that means the fourth root of 16 is 2. I only need to write this number once as my answer. And then finally, there's this one. It says negative 16 to the power of 1 over 4. Well, again, I see a power that's a fraction. When I see a power that's a fraction, I don't really like those. So instead, I'm going to turn it into a radical. And not just any radical. Remember, we always have to think about the index. And the index for this problem is, if there's a 4 here at the bottom, then that's the index for my root, for my radical. And then, of course, on the inside, well, this time, look, the negative is in the parentheses. Then I need to bring the negative inside of this parentheses. So I'm going to call it a negative 16. So here we go. We're going to try to see if we can figure out what the answer will be here for this number. Or actually, I should say, I'm going to think about 4 times. What number do I multiply 4 times to get a negative 16? Now I know what you're thinking. Look, I got a 16 here. 1, 2, 3, 4. 1, 2, 3, 4. So you would think, oh, the number 2. 2 times 2 times 2 times 2. Yeah, that's 16, but I need a negative 16. So here's a common mistake. People go, oh, then just make them negative. Because remember, they all have to be the same. Well, if you try this on the calculator, let's see, here we go. Let's give it a try. I'm going to put negative 2 times negative 2 times negative 2 times negative 2. Still a positive 16. So you see, this does not give me a negative 16. This right here actually equals 16, not negative 16. But is there any other number that'll work? The answer is no. There is no way that if you have an even amount of numbers and multiply those with negatives that you will ever get a 16. So what you have to understand is that this is not possible. Can't be done. Some people like to say, well, it's a no solution. Well, we're not solving. So technically, I can't say it's no solution. It's just you're not allowed to do this. We're not allowed to take a fourth root of a negative number. So that's the issue there. And you know what? We're going to write that down as a little note here at the bottom, just for this problem here, because it's the only one that had an issue. So the note is, we cannot take the even root of negative numbers. I'm just going to put the little hashtag for number. We cannot take the even root. So remember, this is an even number right here. So I'm talking about if there's a 2 there, a 4, a 6, an 8, a 10, right? All your even numbers that you can think of. If you have an even number here as an index, you will never be able to take the root of a negative. You will just automatically say, not possible. Okay? So catch up with the note there for a moment. Because now you're going to learn how instead of trying to think of, all right, what's the number? What's the number? What's the number? Man, the calculator can do all of this for you. And as soon as you learn this, it should make your classwork and your homework that much easier. All right. Again, just giving you a moment to catch up with the writing. Now I need you to have your calculator in hand. I want to show you how we can actually do every single problem that we just did up there, and a calculator can do it for you instantly. All right, here we go. So, eyes up, calculator in hand, everybody. This said the cube root of negative 8. All right, so I want to type it into my calculator. And there's a button that we've used before, and that is this button right here. Let me get something bright to show it. This one right here. This is the power button, right? It lets me do any power I want. But if you look right above that button, I don't mean pi, I don't mean that. I mean literally the same button. Right there, it says X root. In fact, look, let me super highlight right there. Let me see if that'll even work for us. Ooh, look at that adjustment. There it is. You see how it says X root? Well, you should already know that if I want to use anything, I want to use this button, but for that, you got to press the second button first to access anything written on top of these buttons. So I'm going to continue to use the power button. This one right here. All right, so let me show you how it works. So I want to do the third root of -8. All right, so I'm going to type in the 3 first. So I press the 3. I press second. Then I press the power button. See, and there it is. That's what I want to see on my calculator. I want to see the third root. I know it doesn't. I know we say you got to write it in the check mark. That's how the calculator shows it. And then we said -8. So press the negative button. There's the 8. And there it is. It matches the answer that we have here. This is how we do any radical that I can imagine. So this was the third root of -8. There's my answer. All right, let's try it again. Now for these, this one has a negative in front. Please don't type those in. If you have a negative in front, just leave it in front. So then I'm going to do the third root. So I go 3, second power button. There's my third root of +8. You should have already written the negative on your paper anyways. So yeah, and there's my answer of 2, which I wrote there after I wrote the negative. And then there's these, right? I needed to do the fourth root of 16. Now, if I see it like this, you should rewrite it. Make it look like this first. Now you can let the calculator do the work. So here we go again. You press 4, you press second power button. There it is, fourth root, and then of 16. So there's my 16, press enter, and look at that. The calculator did all that work instead of me trying to figure out these numbers like I did before, and it's already there. It did it for me. And then, of course, we had this one. Now, I want you to see what the calculator says for this one, just so that you know that when you see this message on the calculator, you know you should have said, oh, not possible. All right, here we go. Fourth root. So 4, second power button, and then negative, not minus, -16. And when you hit enter, look at that. This is the calculator's way of saying, hey, you're not allowed to do this. There's a domain area. We cannot do this at all. That's how you know you should be saying not possible or can't be done, right? Irreducible. There's so many different ways of saying it, but whenever you get this message on a calculator, that's because it's trying to tell you you're not allowed to do this, okay? All right, well, it's time to practice with the calculator there. So here we go. We're going to do a couple more quick ones, but now we're going to let the calculator do it for us. So here we go. Type it in. This one's ready. We don't have to fix anything. Type it in. On your calculator, you should be typing in the fourth root. So 4, right? Second, and then the power button, 81. And if you did it correctly, you should have all gotten the same answer. 3, that's it. Why? Because 3 times 3 times 3 times 3 is 81. And you could try that out too just to check, but why go through all that work when the calculator is doing it for you? Now, if you notice here, this is the exact same problem. So I'm not going to waste my time with the calculator. All I know is there's a negative in front. Okay, well then, put a negative in front. And then the fourth root of 81 was a 3, so there's the 3. Again, I didn't need a calculator because the negative was on the outside. That means I automatically write it down as part of my answer. I don't do anything else with it. So the only ones to watch out for are these. Remember, when you see a power that's a fraction, you need to rewrite it. This one has a 2 in the denominator. So that means when I write this one out, when you see a fraction, you automatically write a radical. The 25 is on the inside, but that index is a 2. Well, then we put a little 2 in there. If you're wondering, what about the 1? Well, that just means we don't need to add anything else. It's just the power of 1. We never really write those. So now I'm ready for my calculator. So type it into your calculator. Now, this is a regular square root. Normally, that would be invisible. All right, if you did it correctly, you should have gotten an answer of 5 right there. If you did it correctly, answer of 5 should be your answer there. Now, this is the one. Here we go. Yes, it has a fraction. Then I'm going to write a radical. That's the new rule today. I look at my index. The index is 2. Or sorry, my denominator's 2. Then write your index of 2. And like I said, if it's a 2, it could be invisible. You can leave it without it. But on the inside, don't forget, there's a negative 25 in here. You got to put a negative 25 there. All right, take a moment. Please type it into your calculator because that's what you need to practice. Today is a big calculator day where we need to know how to type these in because you're going to finish your classwork and today's homework very quickly if you do that. So if you type this into your calculator should have said one thing and one thing only. Let's see. If you did it right, it should have said that, which tells you this is not possible. You do not get a real answer for it. So when something is not possible, it's because there's no real solution. There's no answer. I'll just say answer for short there, if I can spell. It just means there's no answer that you can give because it's not possible. No real answer available. And on Big Ideas Math, well, you'll see it in a little bit. You have the paper anyway that's coming to you later on. We would get no answer for this. Okay. All right, flip the page. Here we go. Last page coming up. Again, it's a short set of notes. So last page. So again, they should have started you off with this one first so that we can understand how to rewrite those other ones. So a rational exponent. Here's the last idea for today. Now, we have the word rational. We have the word exponent. Well, they each mean something. First of all, when you hear the word rational, it just means one thing. You're going to have a fraction. It's just another word for fraction. And a fraction is just another word for division. Exponent, another way of saying that, is a power. And we just said it right now. When you have a fraction in your power, all that means is one thing. We already mentioned it earlier. Rewrite it as a radical. You're going to rewrite it into one of these. That's the main idea. When you have a power that's a fraction, you're going to write it out like this. Just remember, you got to watch out for that index. We got to see what that index will be. So here we have our little note. Okay. So we're still going to write something here on the side. Now, a rational exponent. So if A is equal to 1 over n, to the power of 1 over n, this is what we would call the nth root. If A is equal to 1 over n, then the radical of that would be, well, there's your A, as we mentioned earlier. But again, look at that denominator. If your denominator says n, well, then your index is that n. Again, the denominator is the index. The index is the denominator. They go together. Again, they go hand in hand. Look at that. There's a connection between the two. There's my index. The index is the denominator. So now it looks a little weird like that. So let me just rewrite it. So here's the rule. Rule number 1 for today. or for this section, rule number one is this. If you have a to the power of 1 over n, then you can write it like this. A root of a, but like I said, make sure you write it inside the little check mark looking part. The index matches your denominator, like we mentioned earlier. So let me give you a quick little example here. Let me give you an example of this idea. So if I were to say this, 5 to the power of 1 over 3, that means that I can rewrite this. Because this is a fraction, I'll write it as a radical. There's the 5 on the inside, but my index would be a 3. Why? Because my denominator is the index. My index is the denominator in case I ever have to go backwards. But that's how we would rewrite it and set it up. So there's the example for that first rule. And now we're going to modify the rule just slightly. And here's rule number 2. Rule number 2 says this, okay? If it says a, and yes, it's still a fraction, that's a power. So I know I'm going to bring in a radical. So here's what I was trying to tell you. As soon as you see a fraction as a power, you got to start getting it ready. It's going to be a radical here. So now, if it says m on the top and n at the bottom, now you have 2 letters. Well, 3 letters, right? Because you have the a, but we already know the base goes inside. We don't mess with the base. But it's all about denominators. The denominator is n. And you might say, yeah, but what about the m? Don't worry about that. The denominator is the index. Don't mix them up. That letter m, we actually have 2 options. If there's an m on the top, you can actually write it down with the m on the outside. Or we have another option for that m. Now notice, I'm not going to change this. The n is still here. The a is still there. That didn't change. My other option is to put the m, the power of m, not a regular m, just a power, I could put it on the inside. But I'll tell you right now, this is our go-to. This is what we use the most. That first one, that's why I started with that one. But it does have 2 options with the way we set it up. So that's why, if I give you one last example here before we do the problems at the bottom, the example says this. What if I had a 27 to the power of 2 over 3? Again, our instinct should tell us, hey, I see a fraction, then let me write a radical. I know there's a 27 as a base. Well, the 27 goes inside. We don't change that. But I do have 2 numbers, right, in my power. But we already said your denominator in your power is the index. There it is. It's the index for my radical. So now I know this is a cube root or a third root of 27. And then, of course, that 2 on the top, you can just put it on the outside. And again, that's the one we go with the most. I could write it with the 2 on the inside just for the 27, but we actually use this the most. All right? So again, one of the biggest things in today's assignment is, well, there's 2 things. One, you got to watch out for the word rewrite, and then for the word evaluate. Evaluate is going to mean use a calculator, just letting you catch up with the writing. Rewrite means don't use a calculator. Change the look of it. So here we go. Last examples. So here's what I was telling you. This problem says rewrite it. Then I'm not going to use a calculator. This problem right here says rewrite it. Well, then I don't need a calculator. But when I get to the practice problems and it says the word evaluate, now we need a calculator. All right, so please be careful when you're doing your homework on BIM and your classwork. If it says rewrite, no calculator needed. You're just going to change the look. So first one says rewrite it. All right, I see a radical, I see a fraction. Well, then that just means one thing. Write a radical. They go together. The base is 64. Well, then I'm going to put a 64 inside. And then, of course, there is a denominator of 4. Well, then, there's my index, because the index should be a 4. And finally, because all I'm doing is rewriting, there's a 3 on the top. Well, then you can put that 3 on the outside. There, I'm done. I don't need a calculator. They didn't say evaluate. They just said rewrite it. Then that's how you leave it. And that's what part of your homework and your classwork is like, where they don't want you to do the work. They just want you to practice how to go back and forth between them. Remember, there is technically another option. I do have to bring this up. The other option is still a 4th root, still a 64, but we could put a 3 inside. I'm not sure what BIM wants. I'm sure it's this one, because that's the one we use the most. Okay? But that's it. This right here would be my answer, because all they said was rewrite. Don't use a calculator. All right, here we go again. Look, now we're going to do these a little faster. This one has a power that's a fraction. All right, look, no hesitation. Get the radical going. It has a base of 27. Then put the 27 inside. It's just a regular number. The only one to watch out for is, here's my denominator. There's a 3 down there. Well, then, put a 3 right here. So the only thing left is, oh, there's a 4 on the top. Okay, so then just surround the whole thing with a power of 4. And then that's it, I'm done. No calculator. Why? All they said was rewrite, not to do anything on a calculator. Okay. So look at number 3. It says rewrite again, so no calculator. This time, when you look at the problem, though, you say, hey, it already has one of these. Okay, that's good. That means I'm going backwards now. They want me to go from here, like I did with the 64, and go back to a power that's a fraction. So when I look at this, my base is 6. So that's the first thing I write down. Because it has a radical, I'm going to write the little fraction on top. All right, but here we go. My index was a 3. And if you remember what we mentioned, if my index is 3, then that is my denominator. It goes right there at the bottom. And of course, on the top, well, there's a 2 on the outside. Well, that's where the 2 goes. There is a spot for everything on here. Again, when it's a radical, it means come back to the fraction. When it's a fraction, you go to the radical. We're going back and forth between them. And then there's this one. Now, don't forget, I know you're going to look in here and say, oh, they didn't write anything. The answer is 1. No, it isn't. Remember, in the world of radicals, in here, there's an invisible 2. It is so common in math that we just don't even write it. But it's so common that we don't write a missing 2, but it's there. Remember, they're called square roots. So then, when I rewrite this one, here we go, look, there's my base. I see a radical, so I'm writing a fraction. My index is 2, so there's the 2. The index and the denominator, we said, always go with each other. And then the number on the outside, the 7, well, there's the 7. And I'm done. I don't need a calculator for it. So that brings us to your practice problems here, but we're going to do them together because we're almost done anyways with the entire note. That way you can just concentrate on your classwork and your homework. Hint, hint. If you're trying to finish something faster, I would do the homework first. It is the easier one. All right, so here we go. Evaluate. Now they want me to use a calculator. But before I do, look, let's practice how to rewrite it. If you see a fraction, it means it used to be a radical. The 64 is our number. Well, the 64 is our number on the inside. But like we mentioned, it's got a 3 in the denominator. Then the 3 is my index. Now, there is a power of 2 on the top, so I'm going to give the entire thing a power of 2. And now here's where I'm going to let the calculator take over because it does say evaluate. So I'm going to work with the inside first. Notice I'm not going to mess with that power yet. So I'm going to do the, that's right, that one was wrong, the cube root of 64. So 3, second power button, should look like this, and then the 64. All right, look, so I got an answer of 4. So what that means is all of this, all of that just became a 4. That's it. That's all it became. That 64, cube root of 64 is just a 4. Well, now it says give it a power of 2. So I can do that on the calculator. Now I can just use the caret symbol. I can go 4 power, regular power of 2. And there it is, 16. And just like that, we're done. All right, look at number 6. Here we go. Let's rewrite it. I see a power that's a fraction. No hesitation then. Get that radical. My base is 9. Well, my regular number is a 9, so that's what goes here. But my index is a 2 right there. Well, then I'm going to put a 2 as my index right here. My denominator is 2, so my index is that. And then, of course, there's a 5, so I'm going to give everything power of 5. All right, calculator time. So I'm going to let the calculator take over for this one, just to do the inside part first. And when I type this into the calculator, we'll type it in, take a moment, type it in. And then whatever you get for this is what you should be writing in here. And the square root of 9 is just 3. All right, but now you got to be careful. Look, it's 3 to the 5, not 3 times 5. So 3 power button 5. There you go. 243, big number. All right, so there you go. So again, you have to know how to do powers on the calculator and how to do roots, any kind of root on your calculator. So that's what today's about. That's why you needed to have a calculator in your hand. This should be one of the easier assignments to do because the calculator's doing most of it. And then there's this one. Now, this one's a little weird, so here's how I'm going to write it instead. Remember, the 5 is the index. That can't change. The 22 is the regular size number. But that 3, I'm going to do it like this. Put it out here. So now I want to show you this with the calculator. This is what I need you to see on your calculator. All right, practice along with me. As soon as you write it, let me give you a moment there to catch up. But I definitely need you to practice this with your calculator. All right, here we go. 5th root of 22. 5, second power button, 22. Look at that number. It's not wrong. Don't erase it. Don't do anything. Just leave it. Don't touch the calculator anymore. But I don't want to write that big number down. And you can't even round it. We want that whole thing. So here's what you have to do. Remember, that's what has to go in here. I still want to give it a power of 3. So without doing anything, don't delete it. Just press the power button. This is the calculator taking that weird answer and now giving it, we're going to give it the power of 3. Hit enter. And now I can round it off. So my answer is either 6.3 or 6.4, if you remember your rounding. Well, since the number 8 is next to it, then I'm going with 6.4, because that would be the next number up. And there's my answer. I think the ones on your homework, everything works out nicely. This is the only one that kind of didn't, but it doesn't matter. All right, and finally, last one for our notes. Don't forget, there's an invisible 2 there. If there's no number there, it's always a 2. So, actually, this one's already ready. Look, 2 to the 7, and it has the 9 out here anyway. So this one was actually already ready to go. All right, let's see what we get. Square root of 7. Square root of 7, hit enter. All right, we got a weird number again. That's okay. Don't delete it. Don't do anything. I'm going to give it a power of 9. So remember, just press that power button right away and give it that 9. Remember, this is the answer from before. All right, there you go. Big number. 6,352 point. All right, now remember, when you're rounding, this is how we check it. All right, there you go. You can see the numbers better. My answer either ends in a 4 or ends in a 5. You can't mess with these. Those are done. But my answer is either a 4 or a 5. Well, when I look at the number next to it, it's just a 4. Then the rounding rule says leave it as a 4. The rule is if the number next to it is 5 or bigger, you go up. If not, you just leave it alone. All right, so there you go, everybody. Now remember, your assignment, I would do the homework. So the teacher right now will give you a paper for your homework. I would work on that because it only has 9 questions. And you already saw this is pretty much all you're doing on your homework for the most part, except the last problem you just have to plug in. But this is the idea for today's homework. Like I said, it's shorter. And then you have this page where all you do is look, evaluate. That means use a calculator. Evaluate, use a calculator. Now, again, on these, it says evaluate, but the first thing you should do is write it down. See, the radical goes around it. Why? Because there's a fraction. There's a little 3 right there. And then you put the power of 2 out here. And now you let the calculator take over. So you do need to write these things in. Okay? Set it up. Now let the calculator take over. So you got to do that for all of these. Look, evaluate, calculator, calculator. All of these are calculator problems. And then you get over here and all you're going to do is rewrite it. So you don't even need a calculator there. So they're meant to be quick. Once you get to 13, this is where they review the rules from last time. Use your word wall, use whatever you have, and don't forget, you're only going up to number 16 here. All right, with that said, have a wonderful day, everybody. I will see you soon enough, as long as they don't call me out for another meeting. Have a good day, everybody.